Assalamu alaikum everyone. My name is Mohammad Abdullah Afzal, roll number 21TE53. Uh, Now we conclude lab 3. The objective of this lab is to represent of unit impulse function and unit step function, making unit step function using unit impulse sequence, and thirdly, making any arbitrary signal out of deltas. Firstly, we can move toward task 1. Task 1 is how to represent of unit impulse function in MATLAB. Open editor and write following code snippet and the save file with function name, that is in this case impulse sequence.m. As you can see in the input image, the MATLAB code. In this code, we can observe three things. Firstly, we can shift the unit impulse to right. Secondly, we can shift the unit impulse to left. Thirdly, to multiply the sequence with scalar value and see the effect. Now you can see the result in the output image. Now task 2. Task 2 is how can we represent of unit step function in MATLAB. As you can see in the input image, the function. In this code, we can observe how can we shift the unit step sequence to right, how can we shift the unit step sequence to left, and how can we multiply the sequence with scalar value and see the effect, as you can see in the output image. Now moving forward towards task 3. Task 3 is unit step sequence can be constructed by add shifted impulse sequence. Use unit impulse sequence of task 1 and construction unit step sequence. Is it possible to construct the shift version of unit step sequence by summation of deltas? If yes, then what is required to do so? Secondly, use command pause, hold on and hold off. As you can see in the input image, we can observe firstly, arbitrary signal can be represented by unit impulse sequence. Secondly, use unit impulse sequence of task 1 and construct the following signal. Bolded number is at 0. And you can see the output in the output image. Moving forward towards task 4. Any arbitrary signal can be represented by unit impulse sequence. Use unit impulse sequence of task 1 and construction of the following signal. Bolded number is at 0. As you can see in the input, here is the code. Firstly, we can use arbitrary signals, and secondly, use input impulse sequence of task 1, and you can see the result in the output image. Firstly, we have original signal. Secondly, we have constructed signal using unit impulse sequence, and thirdly, we have comparison of original and constructed signals. Now task 5. Splitting a signal into even and odd parts. As you can see the input image, the MATLAB code, we can split a signal into even and odd numbers. Here is the result of task 5. You can see in the output image. Now task 6. Impulse train can be used for sampling of continuous time signal. Use following continuous time sequence. Firstly, we have time, then frequency, and you can see in the input image we have impulse train that is used for sampling of continuous time signal. We use following continuous time sequences. Make some logic to discretize the above given sequence. Here is the result of the task 6. Firstly, we have continuous time signal. Secondly, we have impulse train for sampling. Thank you so much. That's all about lab number 3, and that's all from my side. Allah Hafiz.